Welcome back. We're going to be working on the problem 3 from the JBMO 2024. We have a number theory problem, 2020 to the power of x plus 2 to the power of y is equal to 2024 to the power of z. Now what we like in these number theory problems, when you're asked to solve some equation in integers, well, with integers we mostly use modular arithmetics. So the most common tactic used in these types of problems is taking the whole equation modulo something, because if these two different things are equal to each other, they will be equal to each other modulo something. So take this mod 3. 2020 is congruent to 1 mod 3. 2 is congruent to negative 1 mod 3. So we get the whole thing, let's call it S, is congruent to 1 plus negative 1 to the power of y mod 3. Now we realize y cannot be even. I mean, it has to be even. It cannot be odd. Because if y is odd, S is divisible by 3, but 2024 is not divisible by 3. And it's a clear contradiction. So y is even, and this gets us z is odd, because 2024 is congruent to negative 1 mod 3, and 2 is congruent to negative 1 mod 3. Like, this is 1 plus 1 that we get here. This is 2, and it's negative 1. So if z is even, it would be 1, but it's not 1, it's negative 1. So z is odd, and y is even. Okay, nice fact to start off. Okay, next thing here we need to do is, like, look at this. 2020. What's the biggest power of 2 that divides 2020? Well, you can just write down, if you divide it by 2, you get 10,010. You divide it by 2 again, you get 505. So it's 2. 2 is the highest power that divides 2002. Like 2 to the power of 2 divides 2020, and 2 to the power of 3 does not divide 2020. So the V2 function of 2020 is 2. Now V2 of 2 is 1, and V2 of 2024 is 3. And why does that help exactly? Because if z is odd, when you multiply, like, you get, so one of the properties of the V2 function is V2, like it's for every prime, x to the power of y is same to the y times V2 of x. So in other words, on the left side here, V2 of 2024 to the power of z will be equal to z times V2 of 2024, or 3z to be exact, which will always be odd. Right? But what if we look at the V2, but V2 of 2020 to the power of x is equal to x times V2 of 2020, and it is 2x, and it's always odd, I mean even. and v2 of 2 to the power of y is same as y. Yeah, it's just same as y, because, but this is always even because y is even. We got that from mod 3. So we have two even, like we have two things. We have two power of 2's that are even. We sum them up, we get something that is odd. In which case could that happen? So, like, if you get something, like, you get 2 to the power of x, like 2 to the power of m times some k, where k is odd, plus 2 to the power of n times, let's just say, d, where d is odd too. What will that give us? We'll take n is more than m, right? This gives us 2 to the power of m out of the brackets, and you get k plus 2 to the power of n minus m times d. And what is this equal to? This is always even, unless this is always odd, unless n equals m, always odd, because you get an odd integer here and an even integer here, because it's divisible by 2, right? So no matter how, and 2 to the power of m is even here, by the way. We know that it's even because we add even to even. M is even. The less one is even, and the bigger one is also even. So, which means that this will never be odd. Like the v2 of this, like v2 of this is just m, and m is not odd. We know that for the fact that m is not odd. So n needs to be equal to m. That's the only case when this will be even. This will be odd, because in that case, you get an odd power here, you get an even power here, right? 2 to the power of m, and you times it by k plus d. And only then will it have a chance to be odd. Only then will it be odd. So what we conclude from here is that v2 of 2020 to the power of x needs to be the same as v2 of 2 to the power of y. Or in the other words, 2x needs to be equal to y. Right? Okay. Now we rewrite the equation. Twenty to the power of x plus 4 to the power of x equals 2024 to the power of z. Now we can take out 4 to the power of x from here, and we're left with 505 to the power of x plus 1 equals to 2024 to the power of z. Now we're going to use something called lifting the exponent, LTE. So we do the same thing we did. We write v2 of this will equal to V2 of that. Okay? So what is V2 of this? V2 of V2 of Mn is the same as V2 of M plus V2 of N. Okay? Which means 2x plus 1. Why 1? Because 505 is congruent to 1 mod 4. And 505 to the power of x will always be congruent to 1 mod 4, and this will always be congruent to 2 mod 4. 2 mod 4. 4. And it will never be divisible by 4, so the most possible value of this, the power of 2 that could divide this, is 1. So 2x plus 1 will be equal to 3z. So z is equal to 2x plus 1 over 3. Now we got a nice thing here, but we do not stop, because listen, 2020 to the power of x compared to 2024 to the power of to the power of 2x plus 1 over 3. This is significantly larger as x approaches infinity. Because I'll take, and the reason for that is x times the ln of 2020. Right? Take ln of both sides, we're comparing it. And here we have 2x plus 1 over 3 times ln of 2024. Right? Take ln of both sides. These are almost the same. Like 0.000, like something different. But these 2x plus 1 over 3 becomes significantly smaller than x as x approaches infinity, right? So 2020 to the power of x is much greater than 2024 to the power of 2x plus 1 over 3 for any large x. So we just need to test small x and see when the equality holds. But for x equals 1, we can see that 2020 plus 4 equals 2024. And that's it, pretty much. Other than that, when x is increasing, 2020 to the power of x will be strictly larger than 2024 to the power of 2x plus 1 over 3. So this x, y, z is 1 to 1 is the only solution. For more interesting problems, subscribe to my channel. Please click the bell button, and see you guys later. Bye.